From ancient starlight to explosive endings, dead stars tell an incredible story of our universe's history. These cosmic remnants aren't just silent witnesses, they're active players in shaping everything around us, including Earth itself. When stars reach their final days, they put on one of the most spectacular shows in the universe. A star like our Sun will slowly swell up to hundreds of times its size, turning into what astronomers call a red giant. Its outer layers glow with a beautiful reddish color as they cool and expand. But bigger stars go out with an even bigger bang, literally. These massive stars explode in what we call supernovas, briefly shining brighter than entire galaxies. During these final moments, the star creates and scatters many of the elements we find on Earth today, like iron, gold, and silver. It's amazing to think that the atoms in our bodies were once cooked up inside dying stars billions of years ago. After stars like our Sun use up their fuel, they leave behind dense cores called white dwarfs, the most common type of stellar remnant in our galaxy. These cosmic tombstones are about the size of Earth but pack the mass of a star into that tiny space. White dwarfs are like cosmic time capsules, preserving information about stars that died billions of years ago. By studying their numbers, composition, and locations, astronomers can piece together how our galaxy has changed over time. Think of them as the universe's record keepers, showing us when different generations of stars lived and died. They're also incredibly useful for measuring distances in space, since they fade in a very predictable way. Now let's talk about neutron stars, some of the strangest objects in space. These are what's left when really big stars die, but not quite big enough to become black holes. Imagine squeezing something with more mass than our Sun into a ball about the size of a city. They spin incredibly fast, sometimes hundreds of times per second, sending out beams of radiation like cosmic lighthouses. A teaspoon of neutron star material would weigh billions of tons. That's how dense these things are. Scientists love studying neutron stars because they help us test Einstein's theories about gravity and space. When two neutron stars crash into each other, they create powerful waves that ripple through space itself and produce many of the heaviest elements in the universe. When you look up at the night sky, you're actually looking back in time. The starlight reaching your eyes has traveled across space for years, decades, or even centuries. Some of the stars you see might not even exist anymore. They could have exploded or faded away long ago, but their light continues its journey through space. Take Betelgeuse, the bright red star in Orion's shoulder. The light we see from it today left the star about 640 years ago. That means we're seeing Betelgeuse as it appeared when medieval knights still roamed Europe. This cosmic time delay happens because light, though incredibly fast, still takes time to travel. Even light from our closest stellar neighbor, Proxima Centauri, takes about 4 years to reach us. Let's explore how dead stars created the building blocks of life as we know it. In the early universe, there were only simple elements like hydrogen and helium. But inside stars, these basic elements were squeezed and heated until they fused into heavier ones. When stars die, especially in huge explosions called supernovas, they scatter these new elements across space. This cosmic recycling process gave us carbon for making life, calcium for our bones, and iron for our blood. Every time you wear gold jewelry or use a silver spoon, you're holding pieces of ancient stars that exploded billions of years ago. These stellar explosions work like giant space factories, creating and spreading the elements that eventually formed planets like Earth. Without generations of stars living and dying, we wouldn't have the rich variety of elements that make up our world today. Let's dive into supernovas, the most powerful explosions we know of in space. When a massive star runs out of fuel, its core suddenly collapses while its outer layers blast outward at incredible speeds. This explosion is so bright it can outshine an entire galaxy of billions of stars. The energy released in just a few seconds is more than our Sun will produce in its entire lifetime. These cosmic blasts send waves of energy and newly created elements racing through space, triggering the formation of new stars and planets. In fact, scientists think a nearby supernova might have helped kickstart the formation of our solar system. These explosions also create beautiful remnants, expanding clouds of gas and dust that glow for thousands of years, like the famous Crab Nebula. When the biggest stars in the universe die, they leave behind something both fascinating and scary: black holes. These cosmic giants are born when a star at least 20 times bigger than our Sun runs out of fuel and collapses under its own weight. The pull of gravity becomes so strong that nothing can escape, not even light itself. The edge of a black hole, called the event horizon, is like a point of no return. Think of it as nature's ultimate vacuum cleaner, but instead of dust, it can swallow entire stars. Scientists have found black holes in many sizes, from ones as small as a city to supergiants at the centers of galaxies that are millions of times heavier than our Sun. These space monsters help shape entire galaxies by affecting how stars and gas move around them. Just like archaeologists use fossils to understand Earth's past, astronomers use dead stars to figure out the age of the universe. These stellar remains work like cosmic clocks. When we look at white dwarfs, for example, we can tell how old they are by how much they've cooled. The cooler they are, the older they must be. The oldest white dwarfs we've found are about 13 billion years old. We can also look at the elements inside these stellar remnants. Different types of stars make different elements when they die, so by studying what we find in these cosmic fossils, we can trace how stars have changed over billions of years. It's like reading the universe's diary, with each dead star telling us a piece of the cosmic story. Dead stars play a huge role in creating new planets and solar systems. When stars explode, they spread clouds of gas and dust through space that eventually clump together to form new planets. We've even found planets orbiting white dwarfs, showing that life after stellar death is possible. These planetary systems give us clues about what might happen to Earth when our Sun dies billions of years from now. The elements scattered by dying stars are like cosmic building blocks. The iron in Earth's core, the gold in our jewelry, and even the calcium in our bones all came from ancient stellar explosions. Some scientists think a nearby supernova might have helped shape our own solar system, sprinkling the area with heavy elements that became part of Earth. Let's fast forward about 5 billion years to peek at our Sun's final chapter. Our friendly neighborhood star will start to run low on hydrogen fuel and begin to swell up, becoming a massive red giant star. As it expands, it will first swallow Mercury and Venus, turning them into cosmic vapor. Earth might survive, but not as we know it. Our oceans will boil away and the surface will become too hot for life as we know it. But don't worry, humanity will likely have found new homes among the stars by then. After the red giant phase, the Sun will shed its outer layers, creating a beautiful ring of glowing gas called a planetary nebula. What's left behind will be a white dwarf, a small, dense star about the size of Earth that will slowly cool down over billions of years. Thanks for exploring the incredible world of dying stars with us today. From white dwarfs to supernovas, these cosmic endings shape our universe in amazing ways. If you enjoyed learning about space, hit like, subscribe, and share with your fellow stargazers.